In the example number 6, we have to find the synchronizing power and the electromagnetic power of a three-phase synchronous motor with EF, which is given as 420 volts, V is given as 400 volts, and EF is given as 400 volts and VF is given as 420 volts, and the access which is given as 5 ohms. We have to find the synchronizing power and the electromagnetic power. We have to find the and power when the load angle delta is first no load, second at 45 degrees, and lastly at 90 degrees. This is again a direct question by the formula which we have studied in synchronizing power and electromagnetic power when we were doing the theory part of the synchronous machine. So we know that the SY and synchronizing power here and electromagnetic power simultaneously. We can find both the things simultaneously. For the first case, when the electromagnetic synchronizing power for no load, when the delta is 0. So for synchronizing power, we know that 3 into EF into V upon XS into cos delta is the formula, and for electromagnetic torque, we have EF into V upon XS into sin delta. We have the formula. In the first case, I can say that the 3 into EF is already given as 400 into V is 420 upon XS is 5 into cos of no load, that is 0 degrees. It means cos 0 is 1. So I can write 1 over here. So it will be equivalent to 100.8 kilowatt. Coming to the electromagnetic power when it is no load would be EF into V, which is equal to, for first case, EF is again 400 into V is 420 into 5 into sin 0 is 0, so I will be getting 0 here as a electromagnetic power. So the first answer here is 100.8, and for electromagnetic power I am getting a 0 here. Coming to the second part of the question, that when it is 45 degrees, so I can have 3 into EF is again 400 into V is 420 divided by 5 multiplied by cos delta, cos 45. After solving this, I can get synchronizing power when it is delta is 45 degrees. I can get that as 71.25 kilowatts. So I can write 75.25 kilowatts here. Everything is in kilowatts. You can get kilowatts from here. In the second case here, would be 400 multiplied by 420 by this formula divided by axis is 5 into sine of 45 degrees, which is equal to 23.75 kilowatts. 23.75 kilowatts. So I get 23.75 kilowatts in electromagnetic power, and this is my synchronizing power. This part is synchronizing power, and this is my electromagnetic power. So similarly, I can find in the third case that when the synchronizing power at 90 degree, so it's 3 into 400 into 450 divided by 5 into cos 90 is 0 again, so I get here 0. And coming to the electromagnetic power, we get 400 into 420 divided by 5 into sin 90 is 1, which is equals to 33.6 kilowatts. 33.6 kilowatts. So I get all the answers, all the 6 answers. When my no load it is 100.8, and for no load synchronizing power is 0, because cos delta is coming, cos 0 is 0, cos 0 is 1. Synchronizing power has got as 100 watt and sin 0 is 0, so I got electromagnetic power as 0. So no electromagnetic power is generated when the delta is 0. And coming to this case, when the delta angle is 90 degree, I can say that the synchronizing power at that time is 0. So it means that the machine is on the verge of instability, and beyond 90 degree, it will be coming in negative. So the power which is supposed to be supplied to the machine is actually taken from the machine. So it will be negative, and from beyond this point, my machine will get into synchronism, and it will not be synchronized with the magnetic field. Here I can say that my synchronizing power is increasing from 90 to no load, and from electromagnetic power increases from 0 to 90 degree. So please remember this thing also. Synchronizing power is 0 at 90 degree, and electromagnetic power is 0 when it is no load, and it is on the no load condition.